Hello. And I'm going to introduce you the work for you. So let's start right now. This is our group topic, work, energy, and power. I'm sure you use this word in your daily life already. Of course, you know what that means. 帮我抬着. But in physics context, maybe the concept of this word will be changed. Work. What work means? Work is when you do something. Every day you go to work, you make a living. This work means. In physics, work is energy transformed by force. It's from Wikipedia. I just want to be sure that it's correct. And this formula is really important. Work equals force times distance. Yeah. There are two factors. It's really important. Influence everything happen to work. So there have some example. The first one is someone pushed the car, but the car didn't move. So with these two factors, we can imagine that because the distance is 0, so the work with the car is 0, so it doesn't have work. And this one, someone is holding the really stuff thing, but keep like don't move. Yeah. So this doesn't have work too. What about the C? This one, the girl is gonna to pick up the stone. Yeah, stone, but the stone didn't move. So this one doesn't have work too. What about D? This one, the man is pushing the little car, the little baby car, maybe, and it have like already moved. So this one have distance and have force. The force is this man applied to the baby car. So based on this formula, work equals force times distance. So this answer will have like it have work. Let's have a block here, and I apply. Let's focus on this. There have a block, and I apply a force that may be 5 newtons, and I move block for maybe 10 meters. So the work that I apply to this block, work equals to, we use this formula, work equals to force times distance, and we can get the work equals to F times C, and the force, which is 5 newtons, and the distance I said is 10 meters. So the work will equals to 5 newtons times 10 meters. It's 50 newtons times meters. I mean 50 joule. We can see 1 joule is equal to 1 newtons time meter. Joule, its unit of work. Let's get this. Unit of work and also unit of energy. Yeah. And we can get another formula. W equals 1/2 m times v squared. And for this we can, and we use this one, plug in here. We plug in here and replace it. It will be F times D equals to 1/2 and v squared. And we can get this. This is kinetic energy. And this one, this situation will be, this is amount of work. So we get this formula. And in like extra situation, perhaps less. And we put like this. Yeah, so it will be height here, h. Yeah, it's equals to distance, but I mean this we can replace to h. So there we can get Fd time equals to m little g times h. Yeah, this is our topic. Thank you for watching.
Okay, so power is rate of doing work. The formula for power is power equal work over time, which is W over T. And then work is equal to Fs. So from this, power can equal to Fs over T. And then S over T is velocity, so power can also be equal to force times velocity. So power is W over T, power equal F S over T and F V. And the SI unit for power is watts or joule per second. Okay, first question. A motor-powered mechanical arm exerts an average force of 890 Newton to push large crates a distance of 12 meters in 22 seconds. Determine the power output required of such a motor. So The given are F equal 890 newtons, distance S equal 12 meters, and time is 22 seconds. And the equation for power is P equal W over T. So in order to find the power, we need to find the work done first. So W equal Fs, which is 890 times 12, which equals to 10,680. So back to power. Power equal 10,680 over 22 seconds. So power equal to about 485.5 watts. The next question, an elevator transport visitors from the ground floor to the 89th floor at speed up to 16.8 meters per second. Determine the power delivered by the motor to lift the 10 passengers at this speed. The combined mass of the passengers and cabin is 1250. The given velocity equal 16.8 meters per second. Mass equal 1250 kilogram. So power equal F V, which is force times velocity. But the problem is we don't know the force, so we need to find the force first. So force equal to mass times gravity, which is 1250 times roughly 10. So force is 12,500 newtons. And back to power, P equal force time the velocity, which equals to 22.1 times 10 over power of 5 watt. Okay, and that's the end of power.
It's time for potential energy. The term of potential energy is the energy that is stored in the result of position. For potential energy, it have two types. One is gravitational energy, and another one is elastic potential energy. So I'm going to call this GPE because it's easier to say, correct? And this I'm going to say EPE. This two force is for gravitational energy. Potential energy is the storage of energy as a result of mass, gravitational energy, and height. And for this is a storage of energy that due to spring constant and amount of compression. M for this is defined as mass, and G is gravitational energy force. And H is height. And for this, K is spin constant. And X is amount of compression of spin. For gravitational potential energy, it's fine to use force gravitational energy because it's about the same with GPE. But for elastic potential energy, it's only force of spin. It's not elastic potential energy. You're going to find that the energy of spin is going to be equal to half kx squared. Alright, I'm going to give you some example of the problem of potential energy. The question is that the potential energy of a 40 kilogram cannonball is 14,000 joules. How high was the cannonball to have this much potential energy? So it's that mass is equal to 40 kilograms. And the potential energy of a cannonball is 14,000 joules. And it's asked how high it is. So you remember that, right? That the formula is P E gravity is equal to mgh. So we just take this m 40 times gravity is always 10. It is in the earth. And height is we don't know. And PE, the given is already said 14,000 joules. So now we're gonna do some mathematics. H gonna equal to 14,000 divided by 400. And height is gonna equal to yes, maybe 35. And the unit of height is meter. This problem is already very easy. The unit of mass is kilogram, and the unit of peak of energy is already joule, and unit of H is meter. That's it.
Kinetic energy is the energy of motion. An object that has motion, whether it is vertical or horizontal, that has kinetic energy. There are many forms of kinetic energy, such as vibration, rotation, and translational. To keep matter, we will focus open translational kinetic energy. The amount of translational kinetic energy that an object has depend upon two variables: the mass of the object and the speed of the object. The formula of kinetic energy is kinetic energy half mv squared, where m equal mass of the object and v equals speed of the object. This equation reveals that the kinetic energy of an object is directly proportional to the square of its speed. That means that for 4 increase in speed, the kinetic energy will increase by a factor of 4. Kinetic energy is a scalar quantity. It does not have a direction, unlike velocity, acceleration, force, and momentum. The kinetic energy of an object is completely described by a magnitude alone.
Alright, for my part, I'm going to explain about mechanical energy. The mechanical energy is the energy that is posed by an object due to its motion or due to its position. Mechanical energy can be either kinetic energy or potential energy. This is an example for mechanical energy by potential energy. This is an arrow and have a man. The man threw the arrow, so it's just like opposed mechanical energy in the form of elastic potential energy. This is an example for as you know, mechanical energy is an object that plus mechanical energy is able to do work. For example, a hammer this is a hammer and this is a nail. A hammer is a tool that utilize mechanical energy due to work. The mechanical energy of a hammer gives the hammer its ability to apply force to a nail in order to cause it to be displaced. Because the hammer has mechanical energy in the form of kinetic energy, it is able to do work on the nail. Mechanical energy is the ability to do work. Alright, let's move to the formula of the mechanical energy. As already mentioned, the mechanical energy of an object can be result of its motion and the result of its stored energy of position. The total amount of mechanical energy is merely the sum of the potential energy and the kinetic energy. This sum is simply referred to as the total mechanical energy, which is. As discussed earlier, there are two forms of potential energy discussed in our course: gravitational potential energy and elastic potential energy. Given this fact, the above equation can be rewritten. This is mechanical energy. E is equal to potential energy of gravitational and spring potential energy plus kinetic energy. The total mechanical energy of this take is that the sum of the potential energy and kinetic energies. The two forms of energy sum up to 50,000 joules. Notice also that the total mechanical energy of in this case, if you don't understand, for another example of mechanical energy is moving water such as river. Another example could be moving objects such as vehicle. So I think now you're gonna easier to understand for mechanical energy. Thank you.